Okay, Assalamu alaikum and good evening to all of you. So let's discuss here. This session is completely free of charge, so everyone can join because this is service oriented. So yeah. And today let's discuss about the 2018 chapter 6 networking. So from 2019 onwards, there is a main question is question number 6 on part B is related to the networking. So let's discuss about the past paper discussion. So while we're working with the past paper, we can learn a lot. So because this session is completely related to the past paper, so I'll try to finish it 2018 and the 2019 past paper. So if not, so we'll continue the coming Monday in 2019, 2020, 2021 and 2022. So this will be helpful for you to understand how the questions are there. So what are the remedies that you can use to solve that questions on so it will be helpful for you to understand. So let's start with the 2018 past paper. So just I'm requesting you to do that before the sessions. So please complete your the past paper session. So it will be helpful for you because I'm just giving the answers means it's not useful for you. So before this session, so please complete your 2018 past paper. So now you do not have enough time. And coming class, let's first you complete your 2019, either the 2019 or 2020. Complete your all your from 2018, 19, 20, 21 and 2022. So it will be helpful because we'll continue the chapter 6 first. And thereafter, we already done more questions from the chapter 5 related to the Karna's maps of posts and all. So therefore, thereafter the chapter 5, your operating system and DFD ER diagram, let's do that unit-wise. So everything is based on your past paper discussion. So please share this links with your friends, those who are willing to participate like this event. So it's completely based on service oriented. So it's free and everyone can join and they can enjoy this one. And let's start with the 2018 past papers. So I'll share with you this pair. Give me a minute and let's show that. Please open your 2018 past papers and I'll show that past papers. Okay. And give me a minute and. Okay, so in your past papers, you may see this 2018 part B, question number 6. Okay. So here, I just read and get the idea. Then you can revise this past paper. Please take a printout or whatever the device that you can use, and you can follow this session. And therefore, here, let's see. I use a. So the company name is XYZ company, has 6 departments. So the production, account, sales department, administration, maintenance, and IT. So the following table shows the number of computers available in each of the department. And each department needs to their own local area network. The administrator has received the class CIP class block and so on. That number is 192.24154. So here, my dear students, I'll give some clue because when you referring these papers, please mark a very important points. So then it will be easy for you to revise again and again. So then just first of all, understand the concept and then you can move it to the answer. So let's do that one. Here the main the part is what is your IP address? So the IP address number is 192.1 sorry 248.154.024. Okay. So the first question is how many addresses are available in the IP address block? Okay, the first question. And I'll take this paper in my another device, then it will be easy for me to explain. And I'm just going to show my only my this board. Give me a minute. Okay. So your question is the second question: what are the first and the last address of the IP address? And the third one, how many addresses are there? How many hospits are required to create the required subnets? And fourth one, after subnetting, write the relevant network address, subnet mask, and allocate range of IP addresses for each department. Just you can use this form. Okay, B, we'll discuss about this B also. So here we have to draw the network diagram. So let's see how to draw the network diagram for this case study. And the C part is relevant to the theory, so we'll discuss one by one. Okay, my dear students, I'll just close this one, so please refer these questions. I'll write it down some important point here. Then the D01, the production, I'm just using a production from and 25 number computers. And for the D2 account, 30 and 18 sales, D3, D4, D5 and D6. And you have administration and maintenance and IT services. So 30, 25, 28. 25, 28. Okay, let's see. The address box is 192.248.154.0 and 24. So the first question is, how many addresses are available in the IP address block? Okay, my dear students, here look at this one. In these questions, they have already mentioned that this is a class C. Okay. So you can put underline for that. An IP address block. So no need to mention that class C, because here, as we know, there is a two concepts are there. Number one, CIDR notation. Number two, dotted decimal notation. So there is a two ways are there to find out the classes. And the third one, and there is a your first octet. From your first octet even you can identify what is your classes. So I don't want to explain it that one, because you know that thoroughly, because there is a theoretical base. So let's focus only this question. So therefore they have already informed that this is a class C. So what is how many addresses are available in this IP address block? Dear students, so look at this carefully. This question is based on this block, which means they have already given that one number 192.248.154.0. From that block, how many hosts, how many the number addresses can be allocated altogether, totally. Yeah? So the first question is how many addresses. So second one, the first address and the last address. I'll come to that point. So I'll just close this screen, and you can see this. You can see my board. Okay, let's see. So here, let's see, my dear students. So the first question is how many addresses are there? Okay, I'll just quickly remove that one. So the class C means, okay, class A, you know, your first octet is your what do you call that? Network. The first octet is network, and the three blocks are using for your we call host. So the B class, so which means 2 to the power 8 is allocated for the network, which means 256. So this is for the 232. Not 32, sorry, 24. For the B block, 2 to the power 16 is allocated for your network address, 65,536. And this is for the 2 to the power 16. And for the C block, 2 to the power 24 is allocating for your network, and 2 to the power 8 is for the host. Okay, so this is your question. So how many address blocks, how many addresses are available in this block? So here 2 to the power 8 means altogether 256 IP addresses are available. Number one. Number two, but you can mention without your network ID and your what do you call that, broadcast ID. Okay, my dear students. Here altogether 256. So without network ID and the broadcast ID. So with network ID and the broadcast ID. So if you are taking all the setup 256, so if you subtract that your network ID and your broadcast ID, then the remaining is 254. So that is your answer. They are asking, actually the question is related to the C blocks, how many hosts are available. They are indirectly asking, give me a minute, that question is, how many addresses are available in the IP address block. The IP address block means this one. So the relevant that IP address blocks are there given by the ISP or the administrator, whatever it is. So I'm receiving this IP address. By using this IP address, how many IP addresses can be retrieved from this IP address block? Number one, either they can ask like. So this question is relevant to your class C. Okay, my dear student. Okay. So therefore, your question number A, Roman number 1 answer is 256 IP address with network ID and the broadcast ID. Or else you can write it down 254 without network ID and the host ID. Okay. So the second question is, what are the first and the last addresses of the IP address block? Okay, what is your, actually the question is relevant to the network ID and the host ID. Sorry, network ID and the broadcast ID. So you know that one, each and every segment that we find out that we know how to, the first address is relevant to your network ID, your last address is relevant to your broadcast ID. Okay, so therefore they are indirectly asking network ID and the broadcast ID for this specific the address block. So what is your first ID? Your first ID, I'm just saying. Your first answer is A1 is 256 or 254 without network ID and the host ID. Net ID, I'm just writing in network ID and the host ID. Okay, my dear student. And your second question is first IP and the last IP. Okay, my dear students. The first IP address is, which means you know that this is the network ID. So this is your network ID. Network ID. The last one is your broadcast ID. Okay. So what is your best IP addresses? So here 192.248.154.0. 192.248.154.0. So the last IP address is 192.248.154.255. So this is your answer. Okay. So why? Because you know that the usable IP we will discuss further about this for this question. So your question number 2 is asking network ID and the broadcast ID. You know the first ID, the very most ID is relevant to your network ID. Your last ID is for your broadcast ID. So then you can identify from this point. So how many addresses are there? 256 means, which means 0 to 255. You know that. So the octal means 0 to 7. Then we are saying the 8 bits are there, 8 digits are there. So which means 8 digit means you have with the 0, we can take it as an 8. So this meantime here 0 to 255 means that is your maximum number. Your first number is 0, the last number is 255. So the altogether we can take it as 256 digits are available in the particular address block, which means the C block. So the C class has 256. Okay. So your second one. Okay. So please understand this question. So they are in this question paper, they won't ask directly the network ID is what, the broadcast ID is what. So here in the format they might give us that details, but if they are asking in the individual questions like this 1, 2, 3, so they might use a different wordings. So how many addresses are available in the IP address blocks? So students are confusing with that IP address blocks means what? So they might using some sort of different answers. Even they might ask, they can ask that what is your IP this subnet mask of this particular IP address block. So you can give answers as a 255. So IP address subnet mask. This is not your these questions. So we will discuss further. But I'm just giving that answer. So 255.255.255.0. So this is your class C subnet mask, and they are asking also that one. Okay. So if they ask here, there is no such a question, but I just give advance about this matter. Okay. So therefore, I just raise it. So what I'm trying to say here, if they ask any particular block, IP address block means it's general term, general. They are asking about the your IP address block and your first IP and the last IP. Is this clear, my dear students? Number 1. Okay. If you have any issues, please send a message via WhatsApp, or even you can contact me, or in a physical class also you can ask, because this is one of your important questions, 15 marks question on only for your this particular question, 6 question. But even there is a minimum 6 MCQs are there in your part 1, the relevant to chapter 6. So therefore, please concentrate on this one. So please just go through, and if you have any other issues, please ask me. That's why I'm trying to show everything is based on your question paper, so then it will be easy for you to understand. Okay. So let's see the third one. The third one means, look at this. How many hosts bits are required to create the required subnets? Okay, my dear students. Now the question is relevant to the subnets. Okay, my dear students, clear, listen. Here, how many subnets are there? What do you mean by the subnet and the subnet mask? So you just go through that lesson. So if you do not have enough idea, please send a message. I will send a screenshot, because we do not have enough time to discuss all of the matter. Okay. So therefore, please request me about this subnet. Subnet mask is a different. Subnetting is a different. Subnetting means, the very simple definition, simple term I can say, that we are purchasing a one set of block, one particular block, IP address block. Here they have given this 192.248.154.0. In this one single block, I have altogether 256 IP addresses are there. But in this particular example, there are 6 different departments are there in a different location, which means there is a small spaces are there. There are different locations, either the floors or the different buildings. What do you mean by that? Subnetting. Listen carefully. Subnetting. Netting is a different. Subnet mask is a different. Subnetting means okay, you are just using that one particular network and dividing into the segment or dividing into the different networks. So that's what you call as a subnetting. In a one particular network, I am dividing into subnets that you call as a subnetting. Okay. So the subnet mask means, so we can find it out that what are the area that is relevant to the network ID and what are the area that is relevant to your, what do you call that, host ID. So here, I'll just briefly explain. I do not, because I'm trying to explain 255.0.0.0. Okay. So this is your network ID. This is your network ID. This is your host. So here, how many numbers are there? 2 to the power 24, 2 to the power 8. The meantime, the B class 255.255 means here. This is what you call as a subnet mask. So subnet mask is a little descriptive. So I'll try to I'll send a message because I'm not going to explain about this one. Please send a request and I'll send a screenshot about that notes. So then it be easy for you to go through that. So, but here, what I'm trying to say here, my dear students, what I'm going to explain here, how many host bits are required to create the required subnets. Okay. Okay. Where is this one? So you can take a snapshot or write it down. Then it will be easy for me to explain it. Okay. Okay. Fine. Here, my dear students, actually, I'm going to explain about the subnet masks. Okay. From that subnet masks only, you can allocate the bits for the subnetting. Okay. Let's see. We are doing that. This is particular. This question is based on your class C. So therefore, the class C means, look at this carefully. 255.255.255.0. This is called as a dotted decimal notation. Okay, this is called as a dotted decimal notation. But here even you can use it like this one. 24/24. Your IP address block is here. So as what you see in your question. Okay, this is 24. What do you mean by this 24? How many bits are allocated for your network portion and the rest remain of the bits are allocated for your host. Okay. Here these both concepts are meaning same. Here this is a notation of decimal. So when you convert this decimal into the binary, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, my dear students, listen carefully. Okay. Here, in this area, in this 255.255, This is what you call as a host area, and this is what you call as a network area. This is a network area, and this is your host area. So then what do you mean by this 24? 24 means, my dear students, here how many bits are there in this network ID? How many? Here 8, 8, 8. 8, 16, 24. Altogether, network is relevant to the 24 bits. So therefore, here they are mentioning 24 means how many bits are available or allocated for your network portion. And the rest of them are for the hosts. Okay. Here, this is the whole scenario. This is the whole scenario means we are taking as a one single block and we are allocating a 256. But here the problem is I am dividing into chunks. I am dividing into subnets. So then we have to allocate some particular bits for the router. The router only the responsibility to identify this network portion and the host portion. So therefore, we have to tell that what are the how many number of subnet are there in my particular area. Okay. So I'll explain further details about this matter when you draw that what do you call that map, network map. Okay. Here, my dear students, now this is your subnet mask. So they are asking how many bits are, because here network ID, you can't take in the network ID. So this is for your network ID, this is relevant to your the ISP and the class C. But within that host ID, how many bits are separated for your hosts and how many bits that you are going to allocate for your subnetting? Okay. Okay. Is it clear, my dear students? Or if you have any other doubts, please ask. And even you can send them a message or call me or whatever it is. So what are the medium you can ask that questions. Okay. Now look at this carefully, my dear student. Okay. Here, how many departments are available in these questions? 6 departments are there. How many departments? 6. Okay. The 6 departments means 6 departments. Okay. 6 departments are there. So how many bits can be allocated? 2 to the power x equal to 66. Okay, in this scenario, you know this is not equivalent to the 6 because you know as we discussed in the binary conversations, you know that binary is starting with the 1 and 2, 4, 8, 16, 32 and so on and so forth. So therefore, you can't take it as 6 as a binary power exponent number. So then you have to apply this into the very close then. Okay, I'll show that. Here, what is your IQ? 2 to the power 1 is equal to 2. 2 to the power 2 is equal to 4. 2 to the power 3 is equal to 8. So then, where I can apply it to this one? Because this is 6. But here, you have only the 4 number of 4. So therefore, you can't take it that one because the rest of the 2s are, you can't use it. So you have a 6 department, you have to allocate the 6 department. But here, this is wrong. But I can apply into the 8 department. I can divide that into 8. So because everything is based on your binary, you can't beyond that binary. We have the separate position, but still we have to follow that even in a VLSM. We will discuss further about the VLSM. But even in the VLSM also, having that binary conversation, the binary based on the binary only you can elect. So therefore, here they are required only the 8, but here the remaining the 2 things are there. You can use it for your future. In the future purposes, futuristic, you can use it. So, but at the moment, you can apply into these three means. How many binary numbers are using? 2 to the power 3 means here just 3 digits are allocated for your subnets. So from this point here 8 bits are using, but in this is your network portion. You can't do it like whatever the number. You can't take the bits from the network portion. This is relevant ISP and all. But this is your host area. It is relevant to your local area. Whatever you want, you can divide it into chunks and all, whatever the things. So, but in here, how many bits can be allocated for this one here according to this scenario? You can have this 3 number. So then these 3s are allocated for your subnet. But the rest of them are 1, 2, 3, 4, 5. 5 bits are there for the host. Is this clear, my dear students? So if you have any other questions, please ask. So the time is. Any issues, please let me know. So if you want to explain it again also, then I can also use it. Okay. I hope you can understand this. So fine. Any problems you can ask. Okay. Okay, so let's see. So this so how many bits can be allocated? 3 bits can be allocated. So you can show these activities also. 2 to the power x is equal to 6. So you can apply into this 6 area, but it's very close to the 8. So there is a remain 2s are there. So even you can use it that particular blocks for you. Any question? No. Fine.